This is the STS-119 Crew interview with Mission Specialist Joe Acaba. Joe, could you give me the story about how and why you decided to pursue being an astronaut?
Sure. It really happened at a pretty young age, and I blame a lot of it on my father and my grandfather. When we were younger as a family, we would get together and we would look at family photos and family films, the old reel-to-reel tapes that we don't have nowadays. And as part of that, my grandfather and my father were really interested in the Apollo missions, and so they'd show us those tapes. So even though I wasn't watching them live, I did feel like I was at that time. And that really got me thinking about space. Also, as a young kid, I liked to read a lot of science fiction, and that opened up just tons of possibilities. And that kind of got me thinking about maybe someday becoming an astronaut.
Did you have a sense at that time about what it would actually take? I mean, it seems like a good goal being a kid.
Sure. I think back then it was just a lofty dream, not really sure what it would take to get there. So really didn't have a big clue on what it meant to really become an astronaut.
Tell me about some of the educational and professional steps you took to actually get to NASA.
Okay. Education-wise, I have both a bachelor's and a master's degree in geology from the University of California in Santa Barbara and the University of Arizona in Tucson. My professional background is quite diverse, and maybe that helped me get to where I am today. I worked for a couple of years as a hydrogeologist in Los Angeles, and from there I joined the U.S. Peace Corps, working in the Dominican Republic as an environmental education volunteer. From there I hopped over to the Bahamas and worked as a the manager of a Marine Research Center, and worked there for a short period of time. And I think all of those steps really led me to become a teacher. And before I was selected here with NASA, I taught both at the high school and middle school level in Florida.
How did those travels outside of the country impact your perspective on things?
I think you get a great perspective on the world outside of the United States by doing those travels, especially serving as a Peace Corps volunteer. And it really applies a lot now with what I'm doing with the International Space Station and that huge international endeavor we have going on there.
Tell me a little bit about the place you consider your hometown and how that place influenced who you've become and what you've accomplished.
Well, I'm a kid from Southern California. I was born in Inglewood, California. But I really consider Anaheim my hometown, which is where I grew up. The landscape is much different today than it was back then. There was a lot more open land, Orange County, so there was a lot of orange groves out there and a lot of room for a kid to explore. And really that's what I did with me and my friends. We'd go out and spend the days, you know, just exploring and having a good time outside. But I think what I really learned about growing up there as I reflect back on that area is how much my parents really sacrificed and worked for us to live in that neighborhood and to move to that area. And it really taught me a lot about working hard and really the importance of family values and how much that meant to my parents, which of course made me realize how important that really is.
As an educator, you presumably believe in the notion that education can take you anywhere. You're about to go to space. So as a living example of that, how would you like to see your example impact kids?
Well, I think you said it correctly about example. I think a lot of times we try to tell kids what to do and really say this is the way it should be done, but I think they learn a lot more by looking at examples, whether it be their parents, in my case, or their teachers that they spend a lot of time with. So if a student were to look at my case and maybe use me as an example, I hope they'll see that, you know, someone that worked really hard in my schooling, in my jobs, I really worked hard, but if you look at all the jobs that I've had up to becoming an astronaut, I've really enjoyed all of them. And so my biggest advice, or if you look at my example, is really do what you like to do and have a good time doing it. And if you do that and you work hard, you're going to be successful.
You were selected as an astronaut candidate the year after Columbia and the year before return to flight. What was it that made you feel that coming to NASA during that time of uncertainty was still the right move for you?
Well, you know, as I look back, I can't say at that time I knew it was the right thing to do. Just happened to be that NASA was looking for a new class of astronauts at that time. So when the accident occurred, I was actually in the process of filling out the application, getting all the appropriate paperwork, and it wasn't until almost a year later that we came in for interviews and the final selection. But when I saw the opening come up that they were looking for a new class, especially looking for educators, I just thought, hey, this is a great opportunity for me maybe to realize the dreams that I had as a kid. And so once I got the phone call and was asked if I wanted to come to NASA to become an astronaut, there was just no doubt in my mind that an opportunity like that doesn't come very often, and I just knew that it was one that I had to accept, and I'm just very grateful that I did.
Sometime since then, now here, we're on the verge of you taking your first space flight. So the decision appears to have paid off. Tell me what it was like when you found out you were going to be making your first space flight.
It was very cool to find out. It was kind of that same feeling that I got when I received the phone call asking me if I wanted to come and become an astronaut. Just something that's almost unbelievable. The realization of a dream, and just a very happy moment, and it's almost hard to describe just the feeling, but I think a lot of people will appreciate it if they've worked hard towards a goal, and once they've reached that goal, they know what I'm talking about.
What kind of reaction did you get from your family?
My family's they're great, very supportive. I think once I was selected for a space flight, the realization of what I was doing maybe sunk in a little bit more. So maybe there's a little apprehension on their part, but they've always been very supportive, and it was great news for the whole family, and we definitely celebrated Acaba style.
Well, you have to expand on that. Tell us about
we'll have to talk about that a little later.
Okay. What's it been like training with your crewmates for this mission? I mean, the relationships develop, and you draw on strengths from other crewmates, and what's that been like?
It has been a fantastic experience. I've been very fortunate to be with this crew. They're just fantastic. They're very, very intelligent, but they're very, very funny. So we have a good time. Once again, going back to having a good time with what you're doing, and we definitely do that. But have a fantastic commander. He's just done a phenomenal job taking care of us and making sure that we're ready for this mission. Like you said, there's been a lot of support, and it's really neat working with a group of people that all have a common goal, and you all don't mind working really hard and doing whatever it takes to reach that goal. And I think we're all kind of there, and whatever you have to do to get the job done, everybody's willing to do that. And so it's just been a great experience, and now I can't wait to go up in space with them, with my new brothers, as I like to call them. It's after spending over a year with people, every single day they do become like family.
And speaking of that, the extension of your crew is the support personnel, the people that work hard for this mission and every mission to make sure it's successful. What do you think about those contributions, and what's it like when you get to actually meet these people during your travels for training?
It's really great meeting all these people, and I don't think most people, I know I didn't realize the amount of work that goes into each and every mission that we have, and it's just a huge base of people that support us, and we're very fortunate that we get to hop in the shuttle and go for a ride and come back. But we really appreciate, and we know how much people are working, whether it be our flight control team, going out and talking to subcontractors, going out to the Cape and talking to the people out there. And what really strikes me is just their enthusiasm. Everyone you talk to, no matter what part they have with the space program, they're excited, and they love what they do, and they know how important it is, and we know that every day they're working hard so that we'll be successful. And it's great to go out there and meet them and hear their stories and share our stories with them.
There's now several Japanese Space Agency components on orbit on space stations. So JAXA has, in effect, become a full-fledged participant on ISS. Now Koichi Wakata will fly up with you guys, and he'll stay there as JAXA's first long-duration space astronaut on ISS. Well, what's it feel like to be able to have a part in creating that milestone?
I think I have a very small part in all that, but it's a great experience. It's been great working with Koichi. I was fortunate that in our class we had 3 other JAXA astronauts going through the astronaut candidate training with us, so that's been a neat experience, and it's very nice to be part of this really a bigger project than just one person. And when you think about the International Space Station, it's a huge endeavor to have this many countries working together, building the space station, and just knowing that if we do want to go and explore outside of Earth and Moon and Mars, it's really going to be an international endeavor. So it's neat to have a small part of that right now, and just looking forward to where we end up.
Joe, could you summarize the main goals of this mission? What are you trying to accomplish?
I think the goals in our mission are pretty specific. We're really looking at getting the S6, the starboard truss, up there and attached, deploying the solar array wings, and that's really our main objective up on orbit. And like every other space mission, I think coming back safe is an important goal, and I think if we can do those three things, then we've had a very successful mission.
Talk about, if you would, some of your key roles and responsibilities as a mission specialist on this mission.
Yeah, I think I've been very fortunate in the roles that I have. I kind of feel like a utility player on a baseball team. I think my commanders referred to me as that a couple of times. So I'm fortunate in that I'll be on the flight deck as Mission Specialist 1, both on ascent and on entry. And that's been a great experience, and I've learned a lot about the shuttle systems doing that. I'll also be working the shuttle robotic arm with Tony Antonelli. So he and I will do a lot of robotic work there. And then I'm also part of the EVA team, and so I'll be doing spacewalks number 2 and 3. And for 1 and 4, when I'm not out the door, I'll be the IV, the person inside, going through the procedures with the 2 guys that are outside. So I'm getting a little bit of everything on my first flight, so it's been just a great training period.
Do you think having so many hats to wear helps you stay more focused?
Yeah, I don't know if it helps me stay more focused. I think we're all pretty focused on what we're doing. I think having parts in many different areas really gives me the big picture of what's going on. So for me personally, it's been very beneficial.
Give us your best description, if you could, of the S6 truss and its attached solar arrays, and give us an idea of how the station will change in both capability and look after that's attached and activated.
Yeah, when I think about the truss segment, the whole truss on the space station, I think of it more as the backbone of the station. It's where, like you said, we have the solar arrays attached, we have batteries there, we have radiators, and we have other components that keep the space station running. So on our mission, we'll be bringing up the final segment of the truss on the starboard side, and we're bringing up the last set of solar arrays. And the space station is definitely going to look different when we leave, which is it's pretty neat. We're going to go up there, we're going to attach that on the starboard side, so we'll have a little bit more symmetry on the space station. It'll look a little bit more balanced, and we'll have those solar arrays out there. So I think people will definitely, if you look at pictures before STS-119, you'll definitely be able to see the difference after.
How would you characterize the work that the STS-126 crew did on the starboard side solar alpha rotary joint, and how that's actually impacted the relevance of your mission?
Yeah, they did a phenomenal job, and it was great watching the work that they did. And of course, we've been very busy with our training, so I haven't seen all the specific data, but I do know that a lot of the work they did lubing up the Sarge, or the rotary joint there, has really improved the functionality of that joint. So it's going to allow us, once we attach our truss, to more effectively use the solar arrays that we're going to bring up there. So what they have done really benefits our mission and just the future of the space station.
On flight day 1, you'll launch an onboard discovery. You'll check out and configure systems for your stay in space. Then on flight day 2, you'll do a limited inspection of the shuttle's exterior. Tell us about that activity.
It's an activity we now do after we return to flight. We want to make sure that on ascent we didn't incur any kind of damage on the space shuttle. So we'll go ahead and we'll use the shuttle's robotic arm, and we'll remove the boom and its sensors, and we'll go ahead and do surveys of both the left and the right wings, kind of along the forward edge where we may incur some damage, and also along the nose cap. And we'll just have the ground take a look and see if they see any damage that maybe they didn't catch on other exterior video.
Then on the next day, the first of several very busy days for both the crew on board Discovery and the crew on ISS, tell us about the activities planned for rendezvous and docking, and kind of highlight what you'll be doing during that time.
Yeah, I think you're right. The first few days are going to be pretty busy, and on rendezvous day, the whole objective is making burns using our different firing jets to get in the proper trajectory to get to the space station. And so we'll spend that day doing small correction burns to make sure we end up in the right spot, which of course where we want to go to the space station. And my job in particular, there's a point in the rendezvous plan where the commander leaves his seat on the front of the orbiter and we'll head to the aft station where he'll go ahead and do the final flying into the space station. So when he makes that change out, I'll then go up to the front and I'll be working with our pilot, Tony Antonelli, to do some of those final burns that lead us up to where the commander actually brings us into the space station. And he and I will work through the timeline and make sure we get to where we need to go.
On flight day 4, then the focus turns to S6 and some joint robotic work between the shuttle and ISS. Tell us the plan for getting S6 out of Discovery's payload bay and finally to the point where it'll remain overnight.
It's a pretty impressive process. You're looking at a very large payload. It weighs about as much as a school bus. That's about 40 feet long that we have in our payload bay. And so because of the configuration of the space station, we're not able to pick out the payload with the shuttle's robotic arm. So we'll actually have to use the robotic arm that's up on the space station, and they will come in and grapple the payload, and they'll pull it out of the payload bay of the shuttle. And then at that point, we will, using the shuttle robotic arm, then take a hold of the payload, and then from there, the space station's arm has to move along the truss segment to a position that they can better attach it on the starboardmost side of the space station. And when they get out there, then we'll go back and hand it off to them. So it's multiple use of each arm trying to get it out of the payload bay and out to where it needs to go on the far end of the space station.
Any good plan includes a contingency plan or backup plan. What backup options do you have at your disposal if, for example, in the unlikely event that one of the arms fails during that process?
Well, of course, we hope that it doesn't happen. There's a lot of redundancy that's built into the systems. There's 2 strings that we have on the station's robotic arm, so if one string goes down, we do have a backup there. But if we don't have the space station's robotic arm, we cannot take the truss out of the payload bay. We don't have that capability with the shuttle arm. So I think that if we were to have some kind of a problem, there's a lot of faith in the people on the ground, the engineers, and I'm sure they would evaluate all the data. And hopefully they can get a workaround that we could actually get it out of the payload bay and get it to where it needs to be to get attached.
The ambitious schedule continues the next day with the first spacewalk of the mission, which is all about getting S6 into position and then attaching it to the station. Tell us how you and your colleagues on orbit will do that.
It's a long day getting the truss out to where it needs to be. We talked about previously how we get the truss out of the payload bay, and that will be located on the starboard side of the space station when we start the EVA. And we'll have Ricky and Swanee going out the hatch on Ricky's first EVA. And they'll go out there, and just like anyone working construction, we have power tools, and we'll kind of balance between the robotic arm bringing the truss closer with those guys out there, actually telling the robotic arm operators how their alignment is and if things look good. And once they go ahead and get it close enough, then it's back to the old-fashioned working with tools and driving bolts and getting that thing attached.
Okay, so then S6 gets installed, and then what happens after that?
Once it gets attached, really the whole EVA is getting it attached, providing power, supplying power to the truss, and then actually going ahead and getting the solar array blanket boxes. We'll spread those out and get those into a configuration that a couple days later we can actually go ahead and deploy the solar array wing. And so the entire EVA is really focused on that, and it'll take the full 6.5 hours for those guys to get it in that configuration.
Okay. We talked earlier about contingencies if you couldn't get the truss out of the payload bay with a failure of one of the arms. What happens if the blanket boxes, for instance, don't unfold like they're supposed to, or something goes wrong with that process?
Well, I think we've learned a lot about deploying the solar array wings and getting the blanket boxes out there. I'm sure we'll have no problems getting the blanket boxes where they need to be for the deployment. Do we know everything about the solar array wings? Probably not. These have been in storage for a while, so there may be surprises, but I think we have a really good understanding of how they work, and I think we've learned a lot from previous experiences. And when you look at procedures that we'll use, we'll have the entire crew. We were actually this morning simulating that, and everyone's involved on the crew. We also have the ground involved, and everyone's looking at something specific, and if we see something we don't like, we'll go ahead and we'll abort the sequence at that point and then evaluate where we are. So we hope we won't get ourselves into a spot where we may do some damage to the solar array wing, and I think we've learned a lot, and we should be in good shape when that time comes.
If mission managers decide that they want to take a closer look at Discovery's exterior, you'll do what's called a focused inspection. Tell us how that procedure happens.
Well, first, we hope we won't have to do a focus inspection, which means that a lot of things went right on ascent. But just like with the S6 truss, we'll have to use the station's robotic arm to help us remove the boom that we used on Flight Day 2 for that inspection. And they'll pull it out for us, and then we'll grab it with the Space Shuttle's arm, and then we'll go to a specific spot that some analysts would have told us, hey, we may see, there may be an issue at this point, can you guys go take a look? And on the sensor package, we have various things we could use. We could use a digital camera, or we have a laser system that we can look at the depth of any kind of damage we may have. So a lot of it will depend on what they see as a potential damage, and how we get there really will depend on where it is, and we'll kind of go from there. So it's one of those things that a lot of work goes into planning some of the robotic arm operations we know we have to do, but this would be something that maybe we don't expect, so there'll be a lot of work done on the ground before we get those procedures.
There's a chance that you might not have to do a focus inspection on that day, the day that it's been timelined for. If that's the case, tell us about what you will, what the plan is to do that day.
Sure. If we don't have to do the focus inspection, which we're all hoping for, then we'll go ahead and we'll move up the deployment of the solar array wings at that time. So if all goes well on Flight Day 6, we'll try to deploy them and make the space station look a little bit different.
Okay. Walk us through the procedure for deploying the solar arrays. How will that proceed?
It's again, it takes the entire crew really to get this to work and for us to see everything that we want to see. So we'll go ahead and we'll have the robotic arm in the right spot so we can have various camera views using the cameras on the robotic arm, but also the cameras we have on the space station. So we'll have a lot of different views. Tony will be on the space shuttle working some operations there, and the rest of the crew will be in the space station, and we all have different tasks, whether it be looking at different components, looking at the solar array as it's deployed. And with that group effort, also including the ground, we'll go ahead and start the deployment. And again, if at any time anyone, whether it be on the ground or on board, doesn't like something we'll see, we'll go ahead and abort, and that's okay to do. We'll take a look and see where we go from there. I think we have a very good plan in place, and we hope to see it go off flawlessly.
You talked a little bit earlier about having had a lot of experience with deploying solar arrays here lately. It's been a kind of a iffy process recently here. Any new procedures in place because of issues with past deploys?
Yeah, I think getting the whole crew involved and really knowing what we're looking for as they deploy, I think we're going to do a better job of that. And again, if the sun gets in our eyes or we just can't see anything, not that anything's gone wrong, we'll go ahead and stop and make sure that we have a clear view the entire time, because the last thing we want to do is have any damage happen to the solar array. So if we can stop before that happens, that's great. But I think we have learned a lot, and that's the main thing we're going to do, is really keep a good eye on it throughout the entire process, and if we need to stop, we'll go ahead and do and evaluate from there.
Okay, the second spacewalk of the mission will be the first of your career. What do you imagine it's going to be like when you float out of that hatch for that EVA?
I don't know if I have quite that much of an imagination that I could even really think about what it's going to be like. I've talked to a lot of people that have gone out and done a spacewalk, and everyone says that it's a little bit different to them. So I'm sure it's going to be, you know, be a little apprehension going out the hatch for the first time. But we train really hard, and what people tell me is that your instinct will go back to the training that you had at the NBL and the big pool that we used to train. So I'll kind of fall back on that for the first part of my spacewalk. But I think it's just going to be an exciting feeling. I hear the views are incredible, so I'm looking forward to that and trying to fit a little bit of work in there.
On that second spacewalk of the mission, you and Steve Swanson will tour the truss, so to speak. Give us an idea of what work sites you'll be at, and tell us what you'll be doing at those spots.
Well, Eb A3 really is a tour of the truss. We're going to start off on the P side, so on the left side of the space station, and we're going to go ahead and prepare some batteries out there for an upcoming mission, STS-119. So we'll head all the way out to the left side, and as we work our way back in, there are a couple platforms that we have that are kind of folded inside of the truss, and we'll go ahead and we're going to deploy one on the port side and one on the starboard side. So it kind of goes from inside the truss, and we'll fold them out, and we're able to use those platforms either for payloads or for replacement parts that come up. They can have power supplied there, so we'll go ahead and deploy a couple of those. And then we're also going to do various tasks along the port side, really looking at kind of future missions. If something were to go wrong on the space station, we're going to prepare different parts of the station so we can deal with those problems. So it's really, I'd say spacewalk number 2 and 3 are really looking ahead to the future and what's coming up.
Okay, assuming S6 has been installed successfully and the solar arrays have been deployed, EVA 3 will be the point where you turn your attention to some other hardware. Tell us what's planned for that spacewalk.
EVA 3 for me is going to be a special EVA. I'll be going out with Ricky Arnold, and we're classmates, so it's pretty neat for us both to go out the door at the same time. And again, on EVA 3, we're looking at preparing the station for future flights, so we're going to go ahead and we're going to relocate one of the 2 seated carts. Those are the carts that go along the front of the truss. We'll take one from the port side and move that over to the starboard side. So I'll be on the robotic arm at that time, carrying this thing over to the other side, and that should be a good time. And then Ricky's going to do some work on the space station's robotic arm, similar to 126, where they went ahead and lubricated the end of the arm, which we used to grab on a payload. So he'll be working on that, lubricating those the snares that are in there. He's also going to be working on the lab area on the SPDM, which is another robotic arm fixture we have out there, getting some covers in place and removing others. And while he's doing that, I'll be doing tasks similar to what I did on EVA 2, but instead of being on the port side, I'll do that on the starboard side. And so we kind of have a little bit of everything going on EVA 3.
And then what's the plan for the 4th and final schedule EVA of the mission?
The 4th EVA we have will be Steve Swanson and Ricky Arnold going out the hatch again. And Swanee will be going all the way out to the Japanese module. So he'll take quite a tour going out there, and he'll be installing a new GPS antenna over there on that module. While he's doing that, Ricky will be taking both infrared and digital images of a couple of the radiators that we have on the space station, so he'll be doing that at the same time. They also have some of those payload attached systems that they'll deploy. We have a couple more of those on the starboard side, and they have another antenna that they need to go ahead and deploy.
Okay. After your work on ISS is done, you and your crewmates will eventually depart the station. As you're pulling away, you'll get your first big picture views of the station with a fully built out truss and all of its solar arrays attached and deployed. How do you think you're going to feel knowing your contribution is going to allow ISS to do more for more people in the future?
I think it's going to be a very fulfilling feeling. I think it's going to be neat to pull away and see the station in its new configuration with the new solar arrays out there. And I think like anyone that may work with their hands, whether you're working in construction or a medical doctor, when you finish a job, you really feel fulfilled, and it's a good feeling. And I think we're all going to be happy to pull away and see the work that we've done, not only for what we see out the window, but like you said, the station's going to have much more capability. We've talked about the International Space Station and what it's there for, and I think now we'll have a lot more ability to conduct the science, which is really why we're out there. And so with the new solar arrays, we'll have that power for our international partners to conduct more experiments, and I think being a small part of that, it's a good feeling.